What's up everyone, Flooding Vent Guys back. So had a request to do driving pressure. Here you have three balloons. So imagine an ARDS, the lung is very heterogeneous. So there's a lot of different areas that have units that could be collapsed, that could be recruitable, or that could be normal. So we're gonna call the blue the normal, which is called the baby lung. So in ARDS, there's a certain portion of lung tissue left over that's normally aerated. We think this is about the size of a small child, so that's where Gattinoni sort of coined the baby lung. The green is what we call this sort of recruitable lung. We try to figure out how much lung we can recruit through things like the recruitment to inflation ratio, or sort of just by guessing and increasing the PEEP and hoping that we are able to recruit this lung. The red balloon is collapsed, atelectatic, full of fluid, surfactant deficient. This may or may not be recruitable. We certainly don't want to damage it with high volume and pressure, but we're going to try to set the PEEP in order to recruit the green, which is the recruitable lung, and try to get it to be inflated and stay inflated and not go through the different traumas. So atelect trauma, valvular trauma, barotrauma. So the first thing we're going to do is set an appropriate total volume. Generally somewhere between 6 to 8 cc's per kg. This is where we're going to limit our total volume, so we limit our plateau pressure, so we don't damage the baby lung, which is what's left over, as well as not propagate damage in the recruitable lung and the atelectatic lung. So that's the first piece of driving pressure, is the plateau pressure, based on the volume. Now, you can make the driving pressure better immediately if you drop the volume, but if you recruit more lung, you then make everything better. So any amount of volume is going to go over a bigger area of the lung, so the pressure is ultimately going to be lower, but you're also going to recruit lung to participate in gas exchange. So the next thing is you have to set your PEEP. How you set your PEEP, what is the optimal PEEP, these are all things that, so if you set an appropriate amount of PEEP, what you're going to do is keep the baby lung inflated, you're going to recruit the green lung, which is the recruitable lung, and then you might even recruit the red lung that was de-recruited, atelectatic, and full of fluid. Now this is an expiration, so this is a PEEP. Now, ideally in inspiration, the balloons wouldn't be that much bigger. So we put in a total volume, the plateau pressure is less than 30, and our PEEP is some number that has recruited lung in expiration, and during inspiration, it inflates with the total volume that you've given that is appropriate for the size of the lung, so you don't damage the baby lung. You've recruited recruitable lung, and you even might have recruited lung that you thought was not recruitable, or you've influenced the physiology of the lung such that you're able to recruit the lung. So now the pressure and the volume is spread over all these lung units instead of just one lung unit or two lung units. And remember, the balloon example is a little simplistic, but the lung is actually connected in intraalveolar, intrabronchial, and bronchial-alveolar channels, all different names, pores of Luschka, pores of Kohn, etc. So this is an inspiration. So inspiration, then in expiration, we would go down to the PEEP, and the idea with driving pressure is that there won't be that much of a difference. So the lung went from sort of to here in expiration, less than 15 centimeters of water. We know that correlates with survival, mortality, etc. If you have a lot of excursion in the lung, so